person in
Can you refresh, or it's done?
Production. He's the author of the Reporter Suite, the AWR packages for working with Amazon, PhotoR, if you're going through the Python side of things. Anything else? Oh yeah, FBR ads for working with the Facebook API. So let's give him a warm up.
Wow, thank you very much, Neil. You're way too kind. So I'm from System 1, where there are a lot of smart people, and we have got some very interesting business problems as well. I will not talk about that. So no business problems, no stats models at all, but I will concentrate on using R in production, hopefully successfully. And this is a lot of fun, but sometimes not trivial, because I think R doesn't have the traditions like Java and all the other computer science languages using in production. It's mostly used for ad hoc scripts and so on, and building models, but not really running in the cloud. When I realized how ambitious title I gave to this talk, I was a bit frustrated, so I decided to step back a little bit and not only concentrate on the cloud part, but also in general how to write R scripts for production. So I will start at a general level, came up with some suggestions how to write like R scripts so that those would run 2 years later as well without touching those. And then we will get to the more messy and cloudy bits. Well, another interesting fact about this slide, as you may see, included an animated GIF here. I've been using LaTeX and Beamer for like 15 years, and I had really hard time including animated GIFs there. Now I switched a framework, and I think I overdone that a little bit. Sorry for that, but there will be some slides like this one. So just like all data science project, let me start with a quick ETL, and by ETL I mean extracting information from this great audience. So let me just quickly ask and raise your hand if you have ever written an R script to be run in a non-interactive way, so like outside of RStudio. Okay, that's pretty good, thank you. Have you ever scheduled such an R script to run without any human intervention? Okay, that's cool. Let's ask a couple follow-up questions. Do you have such an R script running in production right now, like today? Okay, like still like 5 to 10 persons. That's a lot more than I thought, so that's great, thank you. Do you have like central logging set up with like proper monitoring and alerting on all your R scripts? Okay. Are you running those R scripts like on cheap spot instances, created on demand for that specific task, having like a kind of AI, and when I say AI, it's just a bunch of if-then-else conditions, you know, picking like the optimal instance type for your R script based on the history of your R script, like measuring the CPU and memory usage of your script like every second. Okay, very cool. We should have a discussion after this talk. And for the others, hopefully I will be able to show something useful. And we were discussing on a data science Slack channel with some friends what kind of schedulers we are using, and some applications like Jenkins and Airflow and a few others came up. And a friend of mine who has been in the BI consulting data warehousing business for like 20 plus years mentioned that, you know guys, you're just solving the problems we had in the 90s. So he mentioned that all BI consulting firms have developed like their own job scheduler, like data repository and documentation tool, central logging. And as we went on the discussion, a couple other things came up, but I think like all languages have these kind of problems. And now I think we are in a bit easier situation, because nowadays you do not have to rewrite all these things from scratch, but there are many open source tools from which you can just pick your favorite. Like I just included a couple here, like Jenkins is a well-known tool for like software developers for automated compiling the software tests, unit tests, and so on. Airflow Luigi for the Python folks. There are some R packages, being able to schedule R scripts both on Linux and Windows, and you could use like cloud services. So in the next few slides, I will just include a couple of suggestions. These will be very subjective, so when I say, let's say Git, feel free to just replace that with Subversion, CSV, or whatever you like. But hopefully this will be useful. This is 10 seconds, but this summarizes really well my day-to-day job. So let's spend that 10 seconds watching this video. So this is how I feel about my code from time to time. You know, if you're not touching an R script for like half year, and since then you have changed like R packages, it can be really difficult to figure out what you have been writing like 6 months ago. So instead of that, I highly suggest everyone to always use like version control and be like this guy in the front who knows what's happening, relaxing and concentrating on the actual problem, instead of the junior in the background not knowing anything about the code. So make sure to document your code for your future self. And if you're not familiar with Git or any other tools, I just included a couple commands that you can start with, like creating a Git repo from scratch with these few lines, and also like how to contribute to your project. Having the focus on this line, so always create like feature branches and then try to merge to master after like successful PR builders and so on. Second lesson about version control, always use it. It doesn't really matter which one, but it doesn't matter if it's an R package, an R script, any other script, configuration of files for your production system, or it's just a report, or just ad hoc queries like SQL. I think you should always just put it in some kind of version control, because you will need that later for sure. More details, Jenny Bryan's Happy Git with R homepage is fantastic. I think make sure to check that if you are not very familiar with Git, and that's it. Let's switch to the next topic, like coding with style. That's also really, really important. And that style can be basically anything, just be consistent, and probably it's a good option, good thing to check with your colleagues. It can be like the pretty outdated Google's R style guide, or Hadley's style guide from the Advanced R book, or more recently the Tidyverse guide, or you can just make up your own. Just be consistent, that will help a lot. Some related extra hints, not sure if you're familiar with editor config. It's just a standard configuration file for the most common code style things, like the number of spaces used for indentation and so on. Always use linter, which is like a static code analysis tool, making sure and enforcing that code style that you define there. And I think it's really great to include that in a pull request builder, so that your code always gets validated before being merged into production. A couple other suggestions, and I will try to go quickly through these slides. Try to avoid repeating yourself. I think this is pretty common in like ad hoc R scripts, repeating the pretty, almost the same line multiple times. Here I'm just rounding some numbers to 2 digits maybe, because I want to write to Excel or to a database, or just to print to the console. Instead of that, probably it makes much more sense to write a small loop like this one, go through each variable, do the rounding. This is data table syntax, but you could do that in any other packages as well. Or maybe better just to look up all the numeric variables from your data frame and do the rounding there. Or even better, like writing a function which does that, so that later on in your script you can just call round metrics, or even better, put it in your R package, which can be like a small, tiny internal R package that can be used in all your R scripts. What I would also highly suggest is documenting and potentially also open sourcing your code, which will make the code quality a lot better. Just as a quick example, I've happened to write an R package about logging. Writing the code was like a day. Writing the documentation was another week. But that really made sense, because now the code is much cleaner. I had to go back and redesign the API after writing down how this works. And after writing down, it didn't make any sense. So I went back, rewrite the code. So it helps a lot. Picking a permissive license helps if you want to have users. 8 years ago, I picked AGPL for all my R packages, because I was building a software as a service solution, and I thought my competitors should not be able to fork my software without resharing the code. And what I realized that folks did not really start using my package because of the permissive license. Like, I received multiple emails from big companies if I may change the license. Ended up dual licensing many packages. This is a mess. I think it makes much more sense to go with the permissive license. And if you end up building a business on an R package, you can fix that later. A couple other questions I will just get through real quickly. Use the right tools to do that. Maybe create an R package homepage. That's very easy to do nowadays. If you are interested in more of these general things, Jenny Bryan had a great talk last Use R conference. You can find it online. Hadley's Advanced R book is just great, and there are, of course, many, many more general books around this topic. So, oh, this dog should be animated. Anyway, what you could see here is that sometimes you run an R script in a non-interactive way and you have no idea about what's going on there because it's just executing those lines. You have no ways checking the structure of an R object in the middle of the script. So it makes a lot of sense to spend a little time on logging. And there has been really great R packages to do that, like the futil.logger package. Been using that for many years. It was great, but extending that wasn't that easy. The package seemed to be pretty much unmaintained, and when I came up with PRs, for example, to use the glue formatter instead of the otherwise very cool but not so trendy sprintf syntax, had troublesome time to get that merged. So decided to step back a little bit and come up with a more modern and hopefully more flexible logging utility for R. You can see usage is pretty simple. You load the package, you just pass some string to log info, and it will be printed, I mean the actual message with the log level and the timestamp or whatever you configure. And you can use like glue for the string interpolation if you wish. There are some hopefully useful helpers like this log eval function, which will write the actual R command that you run and the result of that. And a few other things, just for quick demo purposes, we have this short R script, which is loading the logger package. Then we are getting the list of packages from CRAN. We are just logging the number of packages being available on CRAN at that time. And there's a loop through all the letters of the English alphabet. And for each letter, we are just counting the number of packages, including that letter, either in upper or lowercase. And then we write a log message with either the trace or debug level, which simply prints the number of packages, including that. Let me run this real quickly. And now this is what you see in the output. If you're running this R script with little r or R script with the quiet mode, there's no startup messages. This is the only thing you see when running this script. So I think this is useful. This package has some other features like colorized output. If you're interested, please check the anatomy of the log request in this package, which makes it hopefully pretty flexible with having a formatter for the message, which can be glue, sprintf, anything else that you like. There's a separate function for the layout, which will put this string in JSON and in a string or whatever you wish, and the appender where you define where you want to get your messages delivered, which is by default the standard out, but it can be a file, it can be a database, it can be Slack or whatever you like. This is a quick example of overwriting the defaults, like setting the threshold to warn level, using the sprintf formatter, changing the layout to JSON here, including the timestamp of the log message, the host name of the machine where we are running the script, the user running the script, the process ID, and the actual message being logged. And overwriting the appender function to write to this file. We have this log debug line here, which will not be shown, hopefully, due to the threshold. And then we have a log warn function call with the sprintf syntax. And then I'm just reading the content of this. So as you have guessed, this is the output. I mean, this is the content of that file. So those log messages can be defined like as you wish. OK, if you're interested in logging, please check the docs. It's supposed to be pretty good. And there are a bunch of other helpers. OK, let's switch to other topics like making database connections. And I'm pretty sure you have written scripts like this. I see that a lot. Let's spend like 5 seconds on these slides. And please someone point out a couple issues about this R script. Anyone? Yes?
Password in plain text.
Oh, yeah, password in plain text. That's not good. Anything else? Yes? No docs here. OK. Let's wait for a third problem. Yes? It will not connect. Maybe. Okay, so there are a bunch of problems. I totally agree that these are actual problems, what you have mentioned. I would add that the main part of this R script is here. I want to run this SQL in this database. Instead, we have like 15 lines here. This is pretty complex for this simple task, like making the connection, doing the actual query, fetching that, making the disconnect. We should do much better. And just to rephrase what Eric said, like having plain text passwords in an R script may be pushed to a private or a public GitHub repo. Well, you can just read what happened to this poor guy. And if you would think that it's not a problem because I'm not pushing like AWS credentials to GitHub, I found some interesting articles there. So if there's an article about like mining Bitcoin with Google's BigQuery, I guess you can do that with Postgres or all the other DBs as well. So please don't push like usernames and passwords to GitHub. Couple options to overcome this issue, like many are using global options for the username and password. The problem is that you really have to deploy that somehow to the production server. Other things like using the KEYRING, which works on Mac, Linux and Windows as well, but it's not really good for like production servers. That's great for your desktop, but that's not how you want to run your production scripts. Using DSNs, you have to get someone to set that up, or another workaround is having like a .my.cnf file or the same for Postgres. The problem is that you really have to get these files with unencrypted passwords to the server. Some other solutions here that I've seen in many R scripts is using like write RDS and read RDS to store the password, which doesn't store the data in plain text, but it's still not encrypted, so I would not suggest going that way. This is much cooler. Gabor Chardy's secret package is doing a fantastic job with PGP keys, but as you can see here, it's pretty complex. You have to set up a vault, you have to have like private and public keys, you have to encrypt, you have to deploy your keys to the remote server. That's how you can decrypt the data. And so it requires some steps to get like the keys to the remote server. Using environment variables makes a lot more sense. You can pass that into a Docker container as well, but still not the best option. You really have to keep that somewhere, for example, here in your R environment file. This is an example of using RStudio's config package, which is really great, like having a YAML file storing your config. So here we have the host name, username, password, and the DB name, but as you can see here, we are still referring to the actual database driver here in the DB Connect section. To overcome that, you could just use this exclamation mark expression syntax in the YAML file so that you can put all your R code into the actual YAML file. And we can do even better. Like I was looking for a way to include encrypted strings in this YAML file so that you can easily and securely push that to your remote servers. And then I found Amazon's KMS. Because I'm not sure who knows about that service, let me just try to quickly introduce this service. So when I first heard about KMS, I was like, this is the dumbest idea that I ever heard, because this works like you have some data you want to encrypt. You send that data in plain text to Amazon, which will encrypt that data for you with a data key you will never have access to. Only Amazon can encrypt and decrypt the data for you. But what's great here, if you have like EC2 nodes running, you can just delegate access to that key with like IAM roles instead of using AWS credentials. So you can very easily grant access to your credentials, and you can very easily revoke those permissions. Like someone leaving the company, you just revoke access, being able to use this data key, and then the problem is gone. It has some complicated issues, like if you like to encrypt, decrypt data more than 4 kilobytes. I have some helpers which should make that much easier, but basically you are generating an encryption key and using KMS to encrypt and decrypt that encryption key that you have to store along with your data. To keep it short, this is a suggested YAML config where we have the encrypted version of the username and password in the YAML file. You can put it anywhere. No one will be able to decrypt your data without having access to KMS. So wrote some small helpers for that, like this dbconfig function, which will not only parse the YAML file, but it will also do like KMS decrypt, which is part of the botor package, on those strings which have the KMS class. So let me just go back here. Here you define that this should be decrypted with KMS, and this function will take care of that. So when you call like dbconfig on this shiny demo YAML list, this is what you get. Now you have the username and the password both decrypted because the machine that I used here had access to KMS. So that was the original code. And this is what we can do now. It's a bit shorter. You just reference the shiny demo database with the dbconfig, but it's still not the best because you're making the database connection, running the query, then closing the connection. So we can actually speed that up a little bit, like creating a db query function, which will do the connection for you, which will close the connection for you, and in between, it will run the actual query and get your results. Well, in practice, this function is a bit more complex. Feel free to check out the docs. It's basically just doing some validation for you and a lot of logging. A quick example, using SQLite on my machine and using a database that's just a temp file. If I run select 42 on this database referenced in this YAML file, this is what you see. We made a connection to SQLite. This is the query that we have run. There's some extra logs like on the number of seconds it took, how many rows we get, and it will just close the connection and you get the result in a nice data frame. Or you can get that in a table or data table object as well that you can just set as a global option for this package. It has some other nice features, like it stores a bunch of attributes, like the attribute of the DB is stored here. I think that idea came from Neil, by the way. The timestamp of the query is stored here and a few other things. And there are some nice features, like you can just run DB refresh on that data frame. And because it has in the attributes the database connection and also the actual SQL, then you can just simply refresh that. Okay, I will just skip these things. This is, I think, an important aspect when you're writing production code. Forking can be pretty painful, especially when this package was using the RJava package in the background, which means that you create a JVM in the background, and when you fork the R process, it will try to use the same JVM, and things can just simply blow up. Nowadays, it's working a lot better since we switched to the Python way of using KMS. Okay, let's just skip all these and let's switch more on the cloud. So in the past, as mentioned, I used RJava a lot because when I was thinking about how to communicate with Amazon, I had the option of using the raw HTTP API, which is pretty complex. It would require a lot of work. For example, what the Cloudy R folks are doing. Instead, I wanted to make that process a bit simpler, so decided to use the Java SDK, but because of the JVM and all the crashes, it didn't work really well, and then decided just to use the Boto-free Python module, because our Studio's Reticulate package made it really easy to integrate. So there's this package, you load it, it will just start a Python process embedded to your R session, and it will load this Boto-free module, and then you can just run some helpers like this. I am who am I will show you your Amazon username. Some useful helpers here, like there's this S3 download file function, which will just get the data for you from S3 if you have access, or some other helpers like S3 read, where you specify the URI of the object, and you just specify what function to use to deserialize that, like read CSV, fread, or something else. Quick examples of the opposite, like writing data directly to S3, so there's no need to create like temp files, with some extra features like compressing the data for you automatically so that you can just upload gzipped JSON to S3 very easily. And a few other helpers. And if you are missing any helpers, please let me know, open a ticket, because implementing this is pretty easy. As you can see here, this is the actual who am I function, where we are just creating a Boto-free client and just using the getUser method on that Python object and just printing the username of the user. So that's pretty easy. Scheduling jobs, highly recommend Jenkins. That works really great. Installation steps, no more than that. And if you're interested in more details, I happen to have a class at the Central European University on using R in production. Try to document every single step in a GitHub README so you can find more there. Couple suggested plugins that you should definitely check. Out of these, Slack notifications, everyone using Slack nowadays, so that works just a lot better than like email. And the job DSL plugin, which lets you define Jenkins jobs in a programmatic way, which helps a lot. And yeah, running out of time, but Docker is a really important piece of having this in production so that you can have reproducible environment for all your jobs. Creating a new Docker image is as easy as here. If you have some Linux sysadmin experience, it will be very easy to use that for creating the Docker images. It's just using an Ubuntu-based image maintained by the Rocker team, which indeed rocks. That's a very cool Docker image base for everything. You're installing packages from CRAN, GitHub, and you're just adding some scripts to your Docker image, and you're ready to go. Here's some examples how to run that, like you build the Docker image, you push that, let's say, to Docker Hub, or you can push that to like ECR or some other Docker repository or registry, sorry, and then running the actual Docker container with your script is as easy as this one. Some suggestions around that. So as said, Docker image should be like reproducible. There are some issues when you are running this, and I think many companies are getting along with using Docker and just installing the most recent version of R packages into the Docker image, and that works in most cases. Sometimes when someone updates like an R package on CRAN or just pushes something to the master branch of GitHub, just as a backup when getting off a train, you can end up in a pretty bad situation if you just happen to install the most recent version from GitHub. So instead of that, what I would suggest, I'm not, well, traditionally I'm not a big fan of Microsoft, but the MRAN service is just great. They are doing daily snapshots of CRAN, so if you just want to fix your packages, I think the easiest way is just to pick a date, like, well, 1st of April, not sure if that's the best, but anyway, you can just pick a date and you can just install the packages having been published on CRAN on that time. Same for GitHub references. Maybe you should just pick a tag or an actual like commit hash. Okay, and a few other tips. Well, I hoped we could get here, like writing wrapper functions for Docker runs so that you can do all the other crazy stuff like starting temporary cloud instances. But, well, I guess it was like my semi-successful attempt to talk a little bit about using R in production. I hope you found it at least a bit useful. If interested in more details, please check that Twitter account out. I will post the slides, and there are many, many references and some extra documentation that might be helpful. So thank you very much.